Oh, spoiler. Thank you. Thank you, everyone. And I want to steal a couple of minutes from this talk for you, if you agree, to please, first of all, thank you. Thank you all for being here. And I see that many of you are here for the first time, and I can assure you, you maybe still don't know how important it is for you and for your career development to be here today and to join these conferences. It's not just about learning new things, sharing knowledges. It's also about creating connections, meaningful connections, to share a personal story. Now, I joined Storyblok, a company that I'm working for, a year and a half ago. And it was a big jump for me because I was working for an Italian company, and then I joined an Austrian-based company, international company. And I knew the company because I met some of the people working at the company here, at this very conference, a couple of years before. So when I applied for the company, I already knew them. So okay, is it for the streaming, I guess? Okay. So well, this is very important for you to be here, and I assure you, you will understand how important it is in a couple of years for your career. And also, I would like to thank GrUSP, because GrUSP, they are doing a really amazing job for the tech communities in Italy, allowing us to be here. And also, they invited me for the keynote today, and I already had the keynote for the PHP Day in this year. So I think I'm the only person in the Italian history that did the opening keynote for a PHP conference and the React conference. So this is something. It's amazing. So back to the things that interest you the most. My talk today is about knowing how things work under the hood. Because I will tell you a secret. You are no longer code writers. You are no longer code makers. Companies don't hire you because you produce code. Like machines can produce code, software can produce software. You're no longer coders. You are architects. You are providing solutions to companies, not code. You're not shipping code. And if you want to provide solutions, you need to understand how systems work, how systems integrate. So for better understanding how systems can integrate, you need to understand how they work inside. And when I want to understand how something works inside and under the hood, then I try to dive deep into its internals. Open source is something that allows us to just open the code, see how it works inside, and try to reproduce it. And so today I will try to explain how the React build works, not the entire build. In fact, this talk is called bundlers, really, because bundlers are a fundamental part of the React build process. The whole build is made by various tools, and there's not just a single build process, not a single build path. You can have your own build path, but everything is built around the bundler. The bundler is what takes every piece and combine them together to build your app and to let you deploy your app. Then there are other tools, because you need to maybe compile TypeScript, you need to maybe link the code, but everything is built around the bundler, which is what makes you run the build and what happens first when you run npm run build. So we want to understand in the first place why we needed to make bundlers. Because maybe it's not that easy to understand that we needed to make bundlers, and we still need them today. Even if there are probably some scenarios where we maybe don't need the bundlers. There are people that advocate against using bundlers. But I think it's important to understand why we needed them and why we still need them today. And I will try to show you how to make a simple bundler. So how a bundler like Webpack works by showing you the code. Then we will build on top of this some concepts, some advanced concepts that you are using today. But all this is a build-up to go to the real goal of this talk, so to explain to you how Vite works and why Vite is different than normal bundlers. And I decided to make this because my company, Storyblok, which is a software as a service, the software itself is not open source. The core is not open source, but we built around the software, built a collection of open source libraries. And Storyblok really loves the open source and is committed to open source. So we fund a lot of projects. We sponsor meetups like this and events. And a year ago, soon after I joined Storyblok, we decided to migrate all of our libraries and SDKs, because we need SDKs, because we basically offer an API. So we also offer SDKs, open source SDKs for you to use with React or others. And we decided to migrate them all to Vite. We were using different bundles at the time. And now we decided to move to Vite. And at the time, I didn't really know how Vite worked and what it is, why is Vite different, and why is Vite now the industry standard. So I decided to dig deeper and understand how Vite works. And that's why Storyblok inspired me in this journey. And also, if you look at the React dev, the documentation website, the first build tool that they suggest is Vite. So Vite is really the standard for React builds and other JavaScript frameworks. I would like to show you a little demo. Can you see the code? Yeah. So imagine this from 2006, 7, 8. So you were building an app, a JavaScript app, front-end app with many JavaScript files. So maybe you were doing something like this, like including your files in your index.html. So you see that here I'm including multiple files, utils.js, calculator, and I'm including the index.js, which is the entry point of my app. And in my entry point, I'm doing some stuff. So I'm getting this result, for example. Where does this come from? I'm getting like this function, the format date. I'm getting a configuration object. I'm doing a lot of stuff. And when I run this, oops. Can I maybe? OK. So when I run this, it happens that I'm printing a lot of data, but how can I be sure where they come from? I cannot be sure. Even if I add an order here, I cannot be sure that this is the exact order in which I'm including these dependencies, right? Because if I reload, I have many network requests, and I cannot be sure that these requests will be completed in this exact order. Even if maybe today I'm not using HTTP, maybe I'm using HTTP2, even streams, but I cannot be sure that all these will complete and in this exact order. And so I can get variable name conflict because I can define the same variable name in different files. I can have function overriding because I can override the same function with a new function with the same name. I pollute the global namespace because everything is global, basically. If I want to share something between modules, between files, actually, I pollute the global namespace. And I cannot control the dependency order. So I need something a bit more. And I will show you the second demo, which is this one. You see that here, I'm importing a single file, which is index.js, using this attribute, type module. This is telling the browser that this file is including modules like ES modules. ES modules are something that we developed a long time ago. It's now a standard. Every major browser supports ES modules. What happens with ES modules in my new app is that I'm importing dependencies, and I am sure that I'm importing exactly this name, exactly this function, exactly this variable, in this exact order. I can also alias things. So for example, these functions, which is defined with the same name in different files, I can rename it, basically, in my import. And so after that, when I call them, I am sure that I'm calling this exact function, this exact variable. And this is huge. So now, if I start this, and I go this, and I check my console here. Now not this, yes. Now you see that I'm importing one single file, and this output is reliable, but still, so browser compatibility is okay, but still, I have some problem, because look at this. I import many files. If you check your network tab, you still are importing them separately. You still are importing them one by one. And this is a problem, because imagine one of these import can fail, steal the order. You cannot control the order. Also, imagine you just need a single function, like a tiny function from a huge library. What happens? You import, you download the whole library just to use a single tiny function in the browser. So this is not good for performance. I need something else. I need something more. I need something like this. You know what this is? This is the output of a bundle. This comes from the Storyblok JS client, and this is what happens after you type build. Something like this. So everything is packed together into a single file. So you have a single file and an optimized file. So how do we do that? So I try to understand how the simplest bundler possibly exists, which is probably Webpack, which is also a standard. It's like Webpack is like the standard for building bundles in many ways. And what's important is that you need to understand how Webpack works internally to build this file. And how it works is by building a graph of all the dependencies that you have in your app, starting by your entry point. So when you run this file, when you run this bundle, I will share the code open source, of course. We'll not go through all the code here. But when we build, the first time that we want to do after we run the bundle is to build this dependency graph. This is a concept that's really important, and it was introduced by Webpack. So you basically start from a root, which is your entry point, and then you start collecting all the dependencies of your entry point. And so a dependency is what is needed by one other file. So you start like building this graph. So you start exploring this graph. And when you have the whole graph, so like this, this is like a recursive function when I go file by file. And for each file, I just build a graph for that dependencies. When I completed all the files, I will build a structure that is similar to this. It's basically this. This is a structure where for every file, so this is the path to my file, I want to have the content of the file, the plain content, the string of the file. I want to have the list of dependencies of my file. I want to have the list of imports and the list of exports. So once I have this, I can build my bundle. The next step is to pack everything together. And to do this, I can show you. So if I run this, I will create my bundle. I put it here. And what happens is that I have one single file. Everything is inside. And you may notice that on top, I have a function. This is called IIFE. This is a pattern that you have in JavaScript where basically you have a function that auto-executes. So when the browser imports this file, it automatically executes. And then I have this function. This is basically how Webpack works, really. I have these functions, which is something that resembles CommonJS. I don't know if you know CommonJS. It's basically a very basic way to just import JavaScript files. With this, I'm basically telling the browser to just take the content of a function, a variable, something, and put it somewhere else. And what happens is now I have the content of all the files. Everything is packed inside this. Okay, so in one single file, I put the content. And this is actually how we can build a bundler. So the steps are, we first build the dependency graph, then we generate the bundle, and then we output it into a directory. So if you want, this is the very basic architecture of the bundle. You start with a bundle, you have the generate, of course, you have a function for reading the module content, and then to build the dependency graph to transform it. This is what you need to build your own bundle. And this is very similar to the original Webpack. If you compare the output of Webpack with the one that you saw before, Webpack basically does this. So it's basically the same thing, this function that auto-executes with all the content of all the files. You have also different bundles today, so you have different ways to bundle your content. Webpack 5 is a bit more sophisticated than one we had before, so we had more features. We can split code. We will see some of them later. So we had code splitting. You have HMR, auto module replacement. You can include different types of assets into a bundle. So imagine you want to also include a media file or a CSS inside the bundle. You can. You can load asynchronously chunks of your code. And then you have something more fancy, like tree shaking, something that we can see after that. And Webpack was actually created by Tobias Koppers, which now works at Vercel. Then we have bundles that are inspired, in a way, by Webpack. So anytime you see a bundle that ends in pack, it's probably following the same rules, the same structure as Webpack. So TurboPack is what Vercel is doing to replace Webpack. So they are doing this. And of course, the development of TurboPack is led by the creator of Webpack. RSPack is basically Webpack in Rust, made by ByteDance, the creators of TikTok. Then you have Rollup. Rollup is now another industry standard. It's a bit different. Rollup is optimized for ES modules. So if you see our mini bundler, it's not ES modules, really. You have like a single file and you load it. But Rollup is optimized for ES modules. So you have ES modules still. Then you have some fancy stuff like scope hoisting. The bundle are optimized. You have probably the best tree, no, one of the best tree shaking. Probably ES build is the best tree shaker. But you have a good tree shaker. We'll see what it is later. And it was created by Rich Harris, which now works at Vercel. Then you have ES build, which is built in Go. And the great thing about Go is that you can use threads. So ES build, when you launch a build, you can use the threads to parallelize your build. And so it's very fast. And it natively supports TypeScript. The bundles are very optimized. And it was created by Ivan Wallace, which is the co-founder of Figma. Then you have Parcel. Parcel is basically a zero config bundle. So it's maybe like Vite. The thing is that you still have parallel builds, you have caching, you have very good tree shaking and hot module reloading, and it was created by Devon Govat. Now, if you remember, or maybe you had a glimpse of how we are parsing our code, it's something like this. So I needed something to understand the import and export structure of my file. And what I did was using regexp. So with a regexp, I can take all my imports or my exports, but this is not really how bundlers can work today, how bundler works. So we need something a bit more complicated, which is the abstract syntax tree. And this is another really important concept. So this is the Wikipedia definition. So the data structure used in computer science to represent the structure of a program, really a text, in fact. So it's a tree because it's a tree representation of your code. And this representation can then be written in a formal language. So of course, this formal representation is what allows a machine to understand the structure of your code. This is why we need the abstract syntax tree. And this is how it works. So imagine something happened. So imagine, okay, that you have this really simple code with a sum, this function, and you see this is the representation in abstract syntax tree of this code. So you see that you have like these formal statements and identifiers for everything. This is not, of course, made for humans, but for machines. And if you want like a graphic representation of this, you can picture it like this. So it's exactly a tree. A machine, of course, will understand that one, but we can understand this one. So it's like our code, but in this representation. Bundlers use parsers, and they use the abstract syntax tree. Probably the most adopted parsers in the industry are Acorn and the Babel parser. Acorn is what Webpack is using. So to use Acorn is very simple. You just require Acorn and you call the parse function in Acorn and you have your abstract syntax tree. So now I want to include my abstract syntax tree and made a bundler which is close to what we can call a production-ready bundler. And so what I did is creating this simple bundler. And so I wanted to include a package.json with my dependencies, Acorn, Terser, we will see later, a configuration, and something that can be extended with plugins. Because what makes Webpack and other bundlers really interesting for us is that we have an ecosystem of libraries that we can use in our bundlers. And for example, we can use Acorn, we can use Terser, Babel, something else. So I included this dependency, which is Terser, and this is what allows me to use Acorn, so the abstract syntax tree, to optimize my bundle and to produce what is close to the actual Webpack output. So if you now run this bundler, and I will share you the code on GitHub later, it's still very simple, but you can use these plugins. So you can parse using the AST, so basically the Acorn parse, and then the analyze module, which will like use the tree shaking and other things, and you will have this output. Because from this, we have this. Because we use Terser, which is using the abstract syntax tree to tree shake our code and to optimize it. So Terser is an industry standard. It's what is used by Webpack and other bundlers. And it's written in JavaScript. Basically, Terser uses your abstract syntax tree, identify the dead branches, drop them, optimizes your functions, your variables. And so it's what allows you to have your final single file and everything is optimized. So your final simple bundler is entirely encapsulated in this slide. This is the final bundler. And you can see also that optimizations are also at the really variable name level. So every byte counts, right? So we are also optimizing the names. We are optimizing everything. We are eliminating dead code. We are eliminating spaces. And we pack everything together. Because when you are downloading a file, the size of the file matters. So we can see some of the advanced concepts that we used building this. For example, we talked about the tree shaking. Tree shaking is about dead code elimination. Actually, tree shaking is a term popularized by Rollup. Imagine you have a tree with branches. Some branches are dead. So you shake the tree, the dead branches drop down. This is the picture that you can make in your mind. This is what happens. So in your source code, you are defining functions, but in the entry point of your app, you're using some of them, not all of them. So when you tree shake this, what you get is a file that doesn't include the functions that you defined but don't use. So your output is smaller. Another concept is the code splitting. So imagine you have a very large application, very large React application, right? You want to bundle it in a single file, but maybe the single file is too large. Maybe you want to split it in different chunks so that you can load only what you need. And that is very important when you have to deal with a slow connection and everything. And so code splitting is the practice of splitting your bundle in separate chunks. I didn't implement the code splitting in my simple bundle, but I tried with pseudocode. So this is something that resembles an actual chunk generator. So basically, you first build your entire output, and then you start creating chunks. When you have chunks, you serve them to the browser like this. In your this directory, you have the entry point, like the main bundle, and then different chunks. So using something like this, which goes and split your code, you can then have chunks. It's very like an example of how we can do that. And then you have the HMR, which is a hot module replacement that goes also in pair with the code splitting. Hot module replacements is that when you are developing, for example, with React, and you see that when you change something in the code, it gets automatically loaded by the browser. It gets reloaded without you needing to reload the whole application, right? This is hot module replacement. So what happens under the hood is that there's something that detects that you changed the one file and then serves the file to the browser immediately, puts the content of the files to the browser. So how you can do that? Something similar to this. So you need to have something that watches what's happening in your file system. So watches for changes. So in this test that I made, I used I don't remember the name of the watcher. I don't remember, but I know the watcher. When something changed, I needed something to push changes to the browser. And what you can use are WebSockets. So when you start a dev server, probably this is what is happening. So the browser is creating a connection to a WebSocket, and then every time something changes in your bundle or in your chunks, you put data into the socket. So the browser can read the new data and replace the module at real time. And this gets us to Vite. 10 minutes to Vite. So Vite has a lot of this stuff that we saw. Vite is not just a bundler, because Vite is like an orchestrator of different softwares, different bundlers. So in Vite, you can have a dev server, you have HMR, you have the pre-bundling of dependencies, you have code splitting, tree shaking, many asset types. Most importantly, you have an ecosystem of plugins. Vite is integrated with any framework. And you also have a unit test, Vitest, which can be integrated into Vite. Also templates that are framework agnostic. And Vite was created by Ivan Yu, which is the creator of Vue.js. I said that Vite is not a bundler because Vite actually uses two different bundlers, one for the dev mode and one for the production mode. So in dev mode, you have a dev server that serves ES modules to the browser, not a single bundler. You have ES modules. In production, you have a bundle. These two different bundles are ES build for the dev mode and Rollup for the production mode. These are changing, by the way. So this year they released Vite 7, and they are now migrating everything to Roll Down, which is another product that Vercel is that the team at Vite is creating. So they will eventually migrate to one single software, but they are using two different modes to build your app, and this is important. It's important that you understand that what you have when you are in dev mode is different than what you will have in production mode. For example, this is what you have in dev mode if you're using a bundle like the simple bundler, or Vite. So in Vite, you have ES modules. You are importing ES modules. Another concept that we discussed briefly, the pre-bundling. When you are in dev mode, ES build is actually optimizing your dependencies, everything in your dependencies. So when you first launch Vite in dev mode, you will see something like this, pre-bundling dependencies. And what happens really, actually this is what it makes it faster than create React app. What happens really is that you will notice in your source code that you are not importing from React, for example. You see that you are importing from /module/React. This is the pre-bundling. This is the pre-optimization that you have. Also, you see, in development mode, you have the server that's responding with the WebSockets. In production mode, you have Rollup, which you can configure. It's opinionated, so it's already pre-configured for you. But if you want, you can configure Rollup too. You have this plugin ecosystem. So right now, the standard for creating a React application is using Vite. So you can create Vite. This is actually a template that the Vite community is maintaining for creating a React website. Of course, you can also create a React server component website, for example. So with Vite, the dev startup is really fast, especially after the first time. So the very first time, you will get some optimization, pre-optimization, so it's a bit slower. But then from now on, the dev startup is really fast. The performance in dev mode are really fast. Also, the hot reloading of your modules is really fast. The ESM, so ES module support is native to Vite. And this is actually, for if you develop SDKs, for example, if you develop application, the source maps that you get from Vite are really accurate, and are really useful if you debug your application. So even for us developers, using Vite provides us with source maps that are really accurate. And of course, HMR is better. Also, if you write JSX, you need to then transform JSX into JavaScript and everything. So with other bundlers, you will need an external dependency. Well, Vite handles JSX transformations out of the box. So you get JSX included into Vite. You don't need to add other dependencies that are probably also harder to configure. I try to also find some downsides of Vite. There are not really downsides, I may say, but one could be that if you need to develop something for old browsers, and I mean really old browser, like before 2016, now you basically can't, because Vite is for ES modules and older browsers don't support ES modules. So if you need an old browser, probably you can't use Vite. What is really important to me is that the dev output, the prod output, they are different outputs. So sometimes it happened that an error occurred in production, and a user tried to debug it in development mode and sending me the output of the development mode. But this is different. It's another thing. So the way it works internally is also different. So you need to understand it. If you want to debug a production bug with Vite, you need to run the production build even locally, because the output is there. The error is there. Also, something that you may find harder is that in development mode, you still have many HTTP requests. You don't have one request with one bundle. You have many HTTP requests. And that means that maybe one of them can fail. You can have errors in one of them. The cache may be interfering. So you need to also understand that the dev mode splits your code, is really serving you ES modules. These are the only downsides that I could find on Vite, but I think you really need to keep them in mind, okay? So now to conclude. Vite is the new default. So for new projects, I think you should really use Vite 7, and I think probably it's the industry standard. Webpack is still used by the enterprise. You know, the enterprise works in maybe in a different level. They still want like legacy solutions, and Webpack is still widely used in the enterprise landscape. You will see many more bundlers that are made with Rust, for obvious reasons, because Rust is faster, it's memory safe, so many tool chains built with Rust will continue to emerge. And one last advice, please always check, or try to check the security advisories, because we saw even recently supply chain attacks affecting the build tool chain, the bundlers. And if you have a CVE that is known, like you have a security hole in your build system, you're screwed. Because every time you build something and you deploy something in production, it contains a hole. I'm done. So thank you very much. This is me. You can find me. Thank you.